problem, we're given a radical function and we have several questions to answer. If one of the answers turns out that it does not exist, we are to write D and E. The first question is to determine the domain. The domain is the set of all inputs that produce a valid output of a function. So there's a couple things that you consider when you're given an equation and asked to determine the domain. First thing is that if ever you divide by 0, division by 0, doesn't matter what the number is in the numerator, this is bad. And I'm going to put my sad face on that. But in this case, there's no division by 0, right? There's no fraction here. The letter x does not appear in a denominator, so there's no chance of ever dividing by 0. The other thing that we tend to look for is when you take the square root of a negative, things go wrong. So for example, the square root of -1 actually can be defined, but not within the real number system. So we're going to say that this just does not exist. So the idea is we don't want the square root of a negative number. So I guess I could say that as if ever you have the square root of a negative number, we're going to call that bad. So one thing to do is to make sure that doesn't happen. So one way to do the problem is to make sure that 2x plus 8 is positive or 0. In fact, 0 is okay. If 2x plus 8 came out to be 0, this would read the square root of 0, which is defined in math to be 0. So you'd get a valid answer. So mathematically, to say that we want 2x plus 8 to be positive is that it's greater than 0. If something is greater than 0, that's just another way of saying that it's positive. So if I can find the solution to this inequality, I will have found the x values that make the radicand positive, and those are the numbers we're going to include in our domain. Those are the numbers that make me happy. Now be careful, it also can be equal to 0. Remember what I said? It's okay if the 2x plus 8 came out to be 0. So what you're finding is the x values that make this true. So you do that by subtracting 8 on both sides. Here you'd have 8 minus 8 is 0, so that simplifies out. And you have 0 subtract 8 over here, which is -8. And then to get the 2 away from the x, since it's being multiplied, to get that to simplify out, I will divide by 2. Now when you divide by a positive with inequalities, you don't switch the sign. Only when you multiply or divide by a negative would you switch that. So this simplifies out. 2 divided by 2 is 1. So my solution is x is bigger than or equal to, this turns out to be -4. So the idea is, if you were to plug -4 into that x value, then what would happen is 2x plus 8 would come out to be 0, and that's part of my domain. It works because the square root of 0 is defined. It's defined to be 0, in fact. And also is the case, if you were to plug in a number bigger than -4, any of them, then what's going to happen is after you replace that x value with a number bigger than -4, after you multiply by 2 and add 8, what's going to happen is that thing will come out to be positive. We consider that part of our domain. That's the whole definition of domain, is the set of inputs for which the outputs would be defined. So my domain is x is bigger than or equal to -4. Determining the vertical intercept. A vertical intercept has to do with the graph. It's the y-axis that is the vertical one. So a vertical intercept basically is the point at which the graph crosses the y-axis here. So if you did label that point, I don't know where to draw it because I haven't found it yet, but it doesn't matter where I put the dot, the x value of that point would be 0. I can't tell you what the y value is because I haven't solved the problem yet, but any point on the vertical axis has an x-coordinate of 0. So my technique for finding the vertical intercept is to set x to 0 and just ask what I would get out. And then while I'm at it, let me explain the horizontal intercept as well, because a horizontal intercept is where the graph crosses the horizontal axis, the x-axis. And again, I don't know whether it's going to be negative or positive, but regardless where you label your dot here on the x-axis, I can tell you for sure, I don't know the x value yet, but for sure the y value would be 0. So it's just the opposite. You're trying to find the input that makes the output 0. Having said that, in the first case, I want to consider what happens when the input is 0 and see what I get out there, and that would give me this point, which is the vertical intercept. So plugging in 0 here, I get that if you replace this with 0, then you have to replace this x with 0 as well. And order of operations indicate that I am to multiply before I add. So this would be 2 times 0 is 0, and then add 8. So I get that f of 0 is the square root of 8, and it is up to your instructor whether they let you leave that as the square root of 8. Some faculty would make you break that down into the following. They would argue that the square root of 8 could be simplified. The square root of 8 could be broken down into a perfect square, which is 4 times 2. And the reason for doing that is at least the square root of 4 would come out nice. In fact, there's a property that says that as long as one of these is positive, and it turns out both of them are positive, you could break this down into the square root of 4 times the square root of 2. And the square root of 4 simplifies out to be 2, and you're left with 2 square roots of 2. So whether you label this point 0 square root of 8, or whether you label it 0 2 square roots of 2, that is up to your individual teacher whether they want you to simplify that radical. Onto the horizontal intercept. Remember the horizontal intercept, and this is true for all functions, not just radicals, that if you're asking for the horizontal intercept and you're given an equation, it's always that you want to determine when the output is equal to 0. So last time it was plugging 0 in as the input variable x. This time it's the output variable here, which is the entire notation f of x that's going to be replaced with 0. So I want the output to be 0. Replacing the output notation f of x with 0 gives me an equation to solve. And since this happens to be the square root, to undo the square root process, you have to square. And what you do to one side, you should do to the other. And in this case, that's not going to do a whole lot over here because 0 squared is 0 times 0. So you're left with what you started with. You're left with 0. Now, the nice thing about this on the right-hand side is that the square root and the squaring process undo one another. So what survives is whatever's under this radical, and you are to never make any changes with that. You are not to change any signs or do anything but just copy down what that was. So you've basically boiled this down to a linear equation. I would start by subtracting 8, and that would get rid of this. This would simplify out. I'd be left with 2x. 8 subtract 8 is 0. I won't write that. 0 subtract 8 is negative 8. And now that I have it down to this form, since the 2 is being multiplied here, I can divide it, and it would simplify out because 2 divided by 2 is 1, leaving me with 1x equals, and then a negative 8 divided by 2 is negative 4. So remember how I said I didn't know where to label it? It turns out that the actual intercept is negative, so it would be over here if you were using it to help a graph. So I have that the horizontal intercept is the point negative 4 comma 0. If you plug in negative 4, you will get an output of 0. Now I didn't think to do this, but at the end of the video, it makes sense for me to graph this and show you that it has those intercepts and show you that the domain actually makes sense as well. To determine f of 5 would be nothing more than taking your general equation f of x and then simply replacing x with 5. So you could think of it as we're copying the equation down, and I'm not going to use the letter x, I'm just going to put a blank here. So here is essentially your function. Whatever your input is x goes here as well, and my job is to replace x with 5. So since I put it here, I have to put it here. That would give me 2 times 5 is 10, 10 plus 8 is 18. So I would get that f of 5 is the square root of 18, and I would be done. Unless you have a teacher that wants you to simplify that radical. So I'm going to show you that if ever you have a number under the square root symbol, that's called the radicand. Anything under a radical is called a radicand. And if that radicand can be broken down into 2 factors, and one of which is a perfect square, then you are to simplify in this manner. So you have to kind of start by even identifying what a perfect square is. And a perfect square number, just to give you some examples, would be 4, 9, 16, 25, and they're never ending. You can get that list just by saying 2 squared, 3 squared, 4 squared, 5 squared, etc. So the idea is what you'd want to do is find the biggest number in this list that divides into 18 evenly. And I noticed that 4 does not go into 18 evenly, but 9 does. So the idea is you would break the square root of 18 into 9 times 2. So the idea is you could simplify further now, and you could say that that can be broken up as the square root of 9 times the square root of 2. And again, this property always is true provided one of the numbers is positive. In my case, they're both positive. So finally, in simplified form, I get that f of 5 is square root of 9 is 3, and I can't simplify the square root of 2. So I get that f of 5 is 3 square roots of 2. So I've answered all the questions. If you're happy, you can stop the video now. But I thought maybe it'd be neat to graph this real quick on your graphing calculator. Go to your y equals, clear out any equations that you may have. Let me down arrow and clear this one. So in my y1, I am going to type the square root, that's second x squared. And I'm going to type in 2x plus 8. And since I think my calculators must be in classic mode, it looks like this. You have to put parentheses around your radicand. And I'm just going to press zoom 6 to get a standard window. And you can see a couple things off the bat. That remember we said that the domain of this is your x values have to be bigger than or equal to -4 because numbers less than -4 would not give us valid outputs. That's clear on the graph. Notice if you were to try to plug in -5, say, notice there's no corresponding y value. And that's because when you plug in -5, you end up with a negative radicand here. And square root of negatives do not give you real numbers, and only real number answers show up on the graph. So you can actually see that at -4, there's 1, 2, 3. See, this is the fourth tick mark here. So this is x equals -4. In fact, let me hit trace and type in -4, enter to show you that the reason that -4 was included, see the line here? The reason -4 was included in the domain is that you get a valid y value out. In fact, it's 0 there. And then any x value bigger than that, there's that symbol right there, greater than, then you'll get a y value and you get a point on the graph, and that's why you see this graph existing to the right of x equals -4. The other thing that would be clear is if I was to press trace and type 0, enter, and I would get 2.828, which is the decimal equivalent to the square root of 8. You could go to your home screen now and type square root of 8 or 2 square roots of 2 and verify that that is indeed the vertical intercept. Notice we already verified the horizontal intercept. That was when I pressed trace and typed in -4. Right there I saw that at -4, 0 is indeed where the graph crosses the horizontal axis right there. Verifying f of 5 would be done by hitting trace, typing 5, enter, and then you'd see the decimal equivalent to the square root of 18, or if you like the version 3 square roots of 2. On your home screen, type 3 square roots of 2, or if you choose square root of 18, and you'd see that you get 4.24 roughly.